Welcome back, ladies and gentlemen. We're moving on to 2.1, day 4. We're going to call this guy intercept graphing. Our objective is going to be to graph equations in ax plus by equals c form by finding their x-intercepts and y-intercepts. Okay, now, don't freak out over the ax plus by equals c form. We've actually been doing this already. Basically, all I'm saying here is I've got a number in front of the x and then a number in front of the y, both on the left side, and then a number on the right-hand side. So something similar to 4x plus 7y equals 22. Okay, that's all I mean by that, so that's nothing new, so hopefully not too shocking there. Alright, moving on to our vocabulary here. Got an x-intercept. Okay, if we're talking about an x-intercept, I'm talking about the point where a line crosses the x-axis. And one thing to keep in mind, an x-intercept will always be, and I'll do this by kind of example I suppose, if I'm talking about an x-intercept, there's the x, there's the y, I'm talking about a point that's going to hit this horizontal axis. Okay, so maybe this point right here is 1, 0, maybe over here this is 5, 0, maybe over here we're at like negative 2, 0. Notice the common theme was always something comma 0. Although we don't know what the first guy is going to be, it's going to be some number, the second guy is always going to be a 0. Alright, now by the same token, a y-intercept is also going to be a point where the line crosses now the y-axis. So it's going to be where the line crosses the vertical axis, and the y-intercept, by kind of twist the same logic around here a little bit, this will be the point like 0, 2, this will be 0, 4, this will be 0, negative 3 or something like that. So now we're going to have the 0 first and then some number second. So as soon as I say x-intercept, I mean something 0. As soon as I say y-intercept, I mean 0 something. So make sure you keep those straight. Okay, so just to put a kind of a more concrete example onto what I just said, okay, for the graph of the right, the x-intercept, okay, again, the x-intercept, when I'm going to hit the x-axis, and I look over here, I see this guy right here. So the x-intercept, again, that point is negative 6, comma 0. So that's our x-intercept for this line. Okay, the y-intercept, again, that's where we're going to find that on the vertical, and in this case it's right here. And again, the coordinates of that point will be 0, comma 4. Alright, so there's our y-intercept in this case. However, note down here, okay, since the 0 half of each intercept is always a 0, mathematicians sometimes abbreviate it by leaving off the 0 when talking about the x-intercepts and y-intercepts. Okay, so if I was to ask you this and you simply said, oh, the x-intercept is negative 6, I'd be okay with that. Likewise, if you just said the y-intercept is 4, that'd be fine. If you prefer to put the 0 in with it, that's great. If you prefer to leave it off, that's great. Just realize that it's acceptable either way you do it. Alright, so now here's how intercept graphing is going to play out. Okay, now again, this is a shortcut, similar to other shortcuts we've talked about, but we're going to be graphing lines whose equations are in the ax plus b equals c form and not in the more user-friendly y equals form. You could do it for that, but I think it's kind of awkward, so I usually only use this if I've got ax plus b equals c to start with. Okay, so first of all, we're going to let x equal 0 and solve for y. And so again, if x is 0 and I'm solving for y, it's going to give me something on the vertical, so that gets me the y-intercept. Then I'm going to switch it around and let y equal 0 and solve for x. So again, if I'm letting y equal 0, that puts me somewhere in the horizontal, so that gets me my x-intercept. And then once I've done that, I can plot my 2 points and draw a line through them. So just pretend for a second I found my y-intercept to be at 6. Let's pretend and I found my x-intercept to be at 2. And once I've got that, I can then go ahead and draw a line through those 2 points, because remember, 2 points determine a line. Okay, that's a little crooked right there, but hopefully you get the idea. Okay, now I'm going to put this to work. Okay, so let's pretend my equation is 5x plus 2y equals 10. Okay, now admittedly what I like to do is make a little xy chart as I do this. So here it is. Boom. Okay, now again, the first thing I want to do is let my x equal 0, and then I'm going to solve for y. So taking this equation, I've got 5 times 0 plus 2y equals 10. Okay, now realistically, if I have 5 times 0, I've got something that is, well, 0. So really, I didn't even need to do that in the first place. So I could have completely left that off as soon as I knew I was putting a 0 in there. So really what I'm looking at is a very simple equation, 2y equals 10, which hopefully, not a big shocker, gets me y equals 5. So I can slide the 5 over in the other half of that chart. Okay, then I'm going to do the same thing, except for the other variable. So I'm going to let my y be 0. So again, I'm going to have 5x plus 2 times a 0, which again, I really didn't need. So that guy's kind of garbage right there. So if I'm looking at 5x equals 10, again, no big shock, I'm looking at x equals 2. Okay, so now I've got myself 2 points. I've got 0, 5, which is right there. Then I've got 2, 0, which is right there. And then again, I get my 2 points, so I can draw myself a line through there, if I can be a little bit accurate here. And there's my line. Okay, the old way, I suppose you'd call it doing this, would be to get this guy in the right form first. So for instance, I'll subtract 5x from both sides here, because we don't like that form, at least for the other technique. So I got my negative 5x out in front, and I've got a positive 10 there. Then I'd have to divide by 2. And then I've got y equals my negative 5 halves x, and then 10 divided by 2 is 5. Okay, so notice that I've got my starting point of 5, and again that always goes on the y, so hey, look, big shocker, it's in the exact same spot. And then I can go down 5 over 2, 1, 2, 3, 4, 5, or 1, 2, and notice that gives me again the exact same point. Although this particular shortcut lets me keep going, so I could go 1, 2, 3, 4, 5, down over 2 more. And again, if I wanted to, I could keep going, but I'm sure you don't want to watch me do that for the next half hour. So I will simply end my line right there. Okay, but notice, both techniques give us the same exact line. It's just a question of having 2 points versus 3 or more. Okay, so let's talk pros and cons, because depending on what your goal is for graphing a line in any given case, sometimes you have one consideration that's more important than another. So here's some pros and cons, so maybe you can decide when to use this and when not to. So here we go. For pros, I've got a speed pro here. There's no need to rewrite your equation when you're doing this, so that'll save you a little bit of time. Okay, also for another speed category on a pro side of this thing, you only need 2 points, so it's less work. We get 2 points, we draw a line, and we're done, as opposed to other techniques where we've had to go with at least 3. Okay, so basically the theme here is pros. This guy is relatively fast. However, cons, accuracy. Okay, if I've got more points, I've got a more precisely drawn line. So by only doing 2 points in this technique, our line is going to be less accurate than by other techniques. So we are sacrificing accuracy by this technique. And then also fractions. Okay, as we do this, we are definitely going to be less likely to get whole numbers when finding your x and y intercepts. So we're frequently going to have to pump points containing fractions. So again, that's another thing. It didn't happen in the last example because I very purposely picked numbers that were a lot nicer, but we are definitely getting some fractions coming up as we do the next few examples. So again, depending on your situation, maybe this is a great technique, but sometimes maybe it's not. Alrighty, so let's take a look at another example. We've got 6x minus 7y equals 14. Alrighty, so again, me and my XY charts, I kind of like them, so I'll kind of drop it down since I have the space here, do a little bit lower to save me some room to do the equation stuff up here. But again, my very first thing I'm going to do is 0 for x. Okay. And again, if you get good at this, eventually, hopefully what you can do is, instead of writing 6 times 0 minus 7y equals 14, after you practice this a little while, kind of like I did in that other example, you just kind of leave that off altogether. And actually the very first thing you write is then the negative 7y equals 14. And if you're really good, maybe you don't even have to write that. But whatever the case, I'll divide through here by negative 7 and get myself a negative 2. So my y is negative 2. Okay, now again, we flip it around and put a 0 in for the y now. And so now I've got 6x minus 7 times 0, which again, hopefully, eventually you don't even bother writing, because really I've just got 6x equals 14. Now here's the bad news. As I divide through by 6 here, okay, 14 and 6 don't divide evenly. Alright, so I'm going to have to deal with whatever fraction or decimal comes out of this, and depending on your point of view, one may be better than the other, but whatever the case, this really reduces to 7 over 2, which as a decimal is 3.5, of course as a fraction is 3.5, or as a mixed number I suppose. So whatever works best for you. If you like the 3.5, great. If you like the 3.5, great. 7/2 I think is a little questionable in this thing, because quite honestly, if I ask where 7/2 is, it's a little tougher to tell that versus the other two forms of that. But whatever the case, I've got 0, negative 2 right there, and I've got 3.50, so here's 2, here's 3, so 3.5 is going to be right about there, and that's my 2 points, so I'm going to draw my line. And again, the bad news is I've just sacrificed some accuracy, because if I had done a third point and it didn't line up with the other two, I'd go, hey, something's wrong. But again, since I don't have a third point that I'm using, I may be wrong and not even know it at this point. So again, technique is nice, but you have to be careful and you have to be really, really sure that you're right, otherwise you're going to have a line in the way wrong spot. Alrighty, I'd like to do one more example just to play worst case scenario, or at least nearly worst case scenario. And here we go. Alright, so I've got my negative 3x plus 8y equals 19. So again, first of all, I've got the form that I want. I do have the ax plus by equals c form. So that lets me know, hey, if I wanted to, and in this case I do, I can make my nice little xy chart and run with my intercept graphing technique here. Okay, so again, instead of writing negative 3, 0, and then canceling it out, I'm just going to go to the 8y equals 19, and then divide through by 8. And then that doesn't divide evenly, but what it does give me is 2.375. Okay, now admittedly in your XY chart I don't need that many decimal places if that's what it comes out to be. I'd say just round to the nearest tenth. I'm sure that's plenty accurate for what we're doing here. So really in my XY chart I'm just going to simply write 2.4. Alright, and then just going with the y as 0 now. Okay, again I've got now my negative 3x, he survives, but then the 8y gets taken out. So again I'm not going to bother writing him and just go with the 19. And now as I divide off my negative 3, what I get, x equals negative 6.3333, etc. It's repeating. Again, no need to try to put that in the xy chart, so I'm just going to stick with negative 6.3. Alright, now again I got my 2 points applied. The bad news is these are both fractions, or decimals now. So I've got 0, 2.4, so 0, 2.4 would land me right about there. Okay, it's admittedly too tough to be very, very accurate here, so just do your best. And I've got negative 6.30, so there's negative 6, negative 6.3 is going to be a little bit past that. Okay, and so just do your best with that. And then again, I'll get my 2 points. So I can do my best job and draw this line here. Hopefully that's pretty straight. And it's extended in both directions, and there's your whole graph. Alright, now here's a couple for you to try. Neither of them is quite as messy as the one I just did. So good luck with them, and I'll see you in class.